chapter 6 at the beginning of Monday. But sure, today's the last full day of new stuff.
All right, guys. So any questions from homework or shit? I don't want to go there yet. Go away. Don't look at that. Okay. Anybody need this handout? Has everybody got this handout? I think we did not do this one yet, so that'll be a good review. Correct me if I'm wrong. Do you need it? Okay. Who else? Oh. I highly recommend if you missed yesterday's lecture that you watch the video. Or if you're tired of listening to me, you can search YouTube for U substitution and watch somebody else. I don't care. Where it makes sense. Just find somewhere that makes sense. Okay. I've written down that last problem at the bottom of that worksheet, yes? Just so I can actually have room. Can somebody tell me what is it about this integral that number one tells me it's not a direct integral, like integral of sine x is what I would call a direct integral, because it's exactly the opposite of the derivative of something. Yes? Why is this not that?
Because there's no derivative of something, you know.
Yeah. First level, I don't know what function has this derivative, yes? And it feels like it's got to be maybe something kind of gross in order for its derivative to be this, potentially, yes? Is everybody with me? Also, if I try to simplify this directly, does it simplify?
No.
Is what would I factor the bottom as?
X plus x.
X times
x.
X plus
Plus
6 and nothing cancels. All right, good. You guys see what I'm saying? So what I'm trying to do for you is, if you're given this kind of problem, this is what you go. Rule out that it's simplify and easy. Because you know I'm going to give you a problem where if you just factor, it just becomes a natural log of x minus 2 or something. So always try to simplify first before you tackle it with calculus. Rule that shit out. All right, we ruled it out. Now, what tells me that U substitution will work? Yeah, there's a function in there that at least the power matches with its derivative, yes? What's the derivative of x squared stuff?
2x.
It's x, right? Well then 2x, yes. But the number I don't care about. So real quick, if I saw a 7th power down here and a 6th power up there, U sub might work. Because there's a part of this whose derivative might be in there also. I really want you guys to understand what I'm trying to say, because that is the heart of it. If you missed yesterday's lecture, I'm not going to try to recapture everything I went through. But effectively what we're doing is we're trying to see the form of this. We're trying to see what form is this in. The specifics don't matter. If we let U equal this, if we let U equal that, and why are we allowed to do that? Because we're in math, and when I don't know something in math, I give it a letter. Do you know what x squared plus 6 is? 6x? I don't know what I'm going to call it U. Because I'm allowed to, damn it. What do I do now with that to try to make the rest of it match up?
So I know you said 95% of the time you was the one that's stuck.
Yes.
So if it's
So see how this is stuck on the bottom?
Oh, okay.
That's what I mean. Like the top is free to move around, the bottom is stuck underneath. Or stuck inside of a square root, or stuck inside of a natural log, or stuck inside of a sine. Yes?
Okay.
Okay. What do I do with this now?
You understand that?
Find the derivative, because here's the idea. Once I identify U sub might work, what I want to do is take everything that's currently about x and I want to replace it with something about U. Not U, but U. Grammar gets weird when you get to U sub.
So it'd be 2x plus 6 and you could factor.
All right, let's see. You ready? So the derivative of U. And it would normally, we would write du dx, but we just automatically multiply the dx up. So what is the derivative of this?
2x plus 6.
2x plus 6
And you
and then you
could
can
factor
factor
out
dx. Yes, don't forget that.
I really want you to understand. When I write du over dx, right, equals that,
Yeah.
and then we just multiply the dx up automatically. Now, what were you saying?
You could
Factor
factor
out
out 2.
2.
Factor out a 2.
And then you just add a 2.
So,
from
can
after.
you find this in there?
Yeah. Yeah.
So I just need this to show up, yes? Okay, let me stop for a minute. Let me stop for a minute. That is not enough if you missed yesterday. Oh my God. You're at least going to see the nuts and bolts of how this approach works. You're not going to necessarily know why it works or what we're trying to do. So if only the damn top was 2x plus 6 or 2 times x plus 3, then I could replace all of that shit with du.
Just multiply by 2.
So if I put a 2 here, just out of nowhere, am I allowed to do that?
Yeah.
You're like, I see your problem, Jeff, but you just forgot something. Let me help you. What makes that legal?
If you put one
If you
half
put
on
them
the
half on half.
Yes. No, I am not a young person, but I'm sure there must be a reference better than my Indiana Jones that more of you guys would understand. I added something and I kind of took it away. Not plus minus, but multiply divide. I put a multiple in that wasn't there before, but I divided by it at the same time. So what did I just do to this integral? Nothing.
So now you could replace
But now
that
can I
with
find
du.
du?
Yeah.
Yes. So I can rewrite this. Go away, red pen. I appreciate it. 1/2. I'm going to leave the integral blank for a moment. Yes? This whole thing is du. So what's left on the top?
Du.
No? Well, sort of, but I like to write it like this. You could write the du up top. I always hated that, but it's up to you.
I'm sorry.
And then what's on the bottom? What do we say this is?
U.
U.
You're on the bottom.
Me. I'm there.
I am everywhere. I am the alpha. Does that interval look better?
Yeah.
Yeah.
I need, I've said this so many times yesterday, and I've never actually said it exactly like this, which surprises me, because it is kind of the way I see this.
This integral has a function on the bottom, and the derivative of that function's on top. You guys see that? It's got a function on the bottom, and his derivative is on the top. Yes? You guys see? Does everybody just tell me? It's okay. Just tell me honestly. If you don't know what the shit I'm talking about, let me know. Does everybody see that? There's a function on the bottom, yes?
Yeah.
There it is. Is its derivative on the top?
Yeah.
Yes, it is. What does this say? There's a function on the bottom.
That's the
Is its derivative
On
on the top? Yes, those are the same structure. Those mean the same thing. Now, why did I leave these blank for the moment? I have to put something here because this is a definite integral, yes? What do these numbers represent?
in between
The-
1 and 3, like
What do you call it?
the area between.
The area. The limit.
It's the
of
x-axis.
the area.
This is the area. This is what the x variable is doing. Find the area under this from x equals 1 to 3. What variable is this one all about? U. So whatever numbers go here have to be what U is doing. If there was a Y, they have to be what Y is doing. Yes?
Yeah, but the U is extracted from.
Exactly. So how do I figure out? So when X is 1, what is U?
7.
Yes. When X is 3, what is U?
9 plus 18 would be 22.
Okay. Does everybody see where 7 and 27 came from?
Yeah.
Yeah, if you look at the values of x, what are the values of x? It goes from 1 to 3. Okay, when x is 1, I use my I'm the one who created you. I have to take you out this one. No. Sorry, that was fun. Somehow I never said that sentence when I'm talking about you, so I say a lot of weird things, but Daddy? No, stop. So when we set up what u is, so when x is 1, I just go back to how I defined the letter u, right? So when x is 1, my definition says u is 7. When and x is 3. My definition says u is 27. So as x goes from 1 to 3, what does u do?
Go from 7.
Goes from 7 to 27. Okay, maybe. Now, real quick, let's finish this up, and then I want to try something I tried yesterday, but I want to do it a slightly different way. What is the integral of 1 over u?
Natural log of absolute value u.
And I'm going from 7 to 27. Now, here's a mistake students make. By the way, when young Jeff was taking this class, I never changed the limits. I would just put 1 in parentheses. And then here, I would bring x back, and then I would shove shit into there. And then, I think my teacher let me do that, and then I got to Calc 3, and I kind of died a little bit, because Calc 3, you want a lot of practice changing your limits. Because in Calc 3, you change your limits, and there's variables in the limits, and it gets really freaky. Okay. So there is another way to do this, because right now, the biggest mistake I see is people change these numbers, but then they also bring that back. Why would it be wrong to plug 7 into this?
Because that's not x.
That's not what x is doing. So either I plug these numbers in for u, or I plug those numbers in for x. So I'd rather just do this. Look, that's nice. So what do we get? We get 1/2 of natural log of,
7. Absolute value of 7.
27.
oh wait, 27, because the top one goes in first, right? Minus 1/2 natural log of 7. Why am I not writing absolute values?
They're all positive.
Yeah. Now you could bring the 1/2 up and use properties. Who gives a shit? That's the answer. Whatever that number is. If this was a word problem, I would want you to throw this in your calculator. Because if I say, how many hours did you work yesterday? And you say, 1/2 the natural log of 27. Shut up. You guys kind of with me? This was not a word problem, so I could just circle this. Okay. What does that represent? The thing I just boxed off.
The area under
The area under the original function?
Under the original function
From
between 1
1 to
and
3. How do I check this on my calculator then?
Just do the
Type the function in and just go second, calc, and then 7.
That's insane, what you're saying. Are you saying this thing that costs 100 something bucks can actually do something? That's crazy shit. So if I plug in, I'm gonna plug in the original one. I'm gonna take all the red shit away. X plus 3 divided by x squared, where'd it go? Plus 6x. I'm gonna hit zoom 6 just to make sure that I get a nice, ooh, look at that. Look at all those, yeah. And then I'm gonna, is everybody kind of with me that wants to be with me? And then I hit second trace to go to calc. I want to calculate, I'm just gonna hit the number 7 so I can calculate an integral. And what was it from? 1 to 3. And look, you see, they're little tiny.
0.67.
Yeah, 0.67? Oh God. Okay, good. It's gone. Is it gone? Is it finally gone? Okay, sorry. So 0.6749 stuff. So let's double check that. If I plug this in my calculator, 1/2 natural log of 27 minus 1/2 natural log of 7, I get same thing. Yes? You guys with me? So on the final, on the test 3, whatever the shit, you're gonna be able to use your calculator. So if you have any definite integral question, you can check it. You can check it. Yes? Always nice. Yes, sir.
One more example, please.
Huh?
Could you go through one example, please?
Yeah, I guess so. Maybe this one that I wrote over. Okay.
Oh.
This one is weird. And this is an example I desperately always try to make sure I show you. This is kind of like a sideways application of U7. So listen. If I would have written, if only I would have written this problem, why is this problem easier?
Because the x is would be the u.
What can I do here? The bottom is one term.
Yeah, you can cancel.
X over X is
1.
1 over X. Yes? How many terms on the bottom in the problem I gave you?
2.
2, damn it, Jeff. What the of shit. Will u sub work the way that we've looked at it so far? What would have to be here for u sub to work? You can do it. Squared. If only there was an x squared, then u sub would work directly. But I am telling you right now, u sub will work.
Just add x squared.
No? Again, you think, I see your problem, but I think, Jeff, you meant to put that there. Could have solved that problem instead. You solve that problem quick and you lose all the points, damn it. So listen. U sub fundamentally is 90-something% of the time you let u equal the piece that's stuck somewhere and you hope it's the rest of it. So if I have stuff inside of a square root, I let u equal that, and I hope it equals, the du equals the stuff outside. Is everybody kind of with me? That's how most u subs work. Yes? 100% of the time, you let u equal the thing whose derivative is in there also. Yes? Now, this is going to feel like I'm breaking my own rule, but I'm not. I'm going to do u sub for a different reason than normal. Don't I wish this was one term? So I'm going to let u equal x plus 1. If I do that, wouldn't this become one term?
Yeah.
Now, what is du, though?
One.
Keep going. 1dx. There you go. Don't ever forget both of those. Trust me. Why would I start down that big one? Do you all agree with that dx is in there?
Yes.
So I didn't go against the 100% thing. What's wrong, though? What is wrong? Can I get all of my x shit replaced with u using what I've written so far? I can replace that with u, yes? I can replace that directly with du, yes? But then what's still in there? That, and you can't integrate x over u, then you've got more variables. That's multivariable calculus, that's calc 3.
You take out a 1 over x?
No. So here's what we do. This is so dumb. This is so dumb when you see this. What is u? What do u mean?
X plus 1?
What are you all about? Yeah, u is x plus 1. So what's x?
U.
There you go. The minute you set up this relationship, that means you've set up the opposite relationship. So, what do I put here?
U minus 1.
U minus 1. What do I put down there?
U.
U. What do I put here?
Dx.
D.
U.
U.
And you cancel out the u's?
No, not yet. Not quite directly. Right? Yeah, we had to. You gotta be on camera. You gotta be everybody.
So just U over U.
Before we get too far, do you all agree with me? There's no x's left.
Yeah.
Everything's u.
Yes.
This integral will work then. What's the one thing I haven't done yet? Before I can really do the rest of the problem. Was it definite?
No.
Was it definite? Yes. So when x is 0, u is
1.
1. When x is 1, u is 2. All right, now how do I simplify the inside?
You split it.
Yeah, u over u is 1, because both of these being divided by u, minus 1 over u, yes? Is that a difficult integral?
No.
Okay.
It'd be 1.
Yeah, what's the integral of 1 du?
Uh,
You can do it. That's why we did that yesterday on the worksheet. Integral of dx, integral of dy, integral of dm.
Oh, just
oh,
It's just going to be
1.
u.
oh, yeah.
And of course the integral of 1 over u.
Natural absolute value.
Yeah, now watch this. I'm not going to write absolute value because I'm a dork. Why am I not going to write absolute value? Because all of my inputs are... okay. But technically, yes, you're right. But do you see how I could be in a specific situation? I don't need those things. So I get 2 minus natural log of 2 minus 1 minus natural log of 1. What's the natural log of 1? Is everybody cool with that? Plug a 2 in. Minus. Plug a 1 in. Yes? Always plug the top in first, bottom in second. 2 minus ln of 2. What's ln of 1? 0. So you got 1 minus ln 2. Yay! Crazy shit. So fundamentally, u sub can be used when there is a function anywhere in your integral whose derivative is in there also. There's one little extra thing I should say. And when you substitute, you have no x's left. Yes? But there's more you can do with u sub, and very often us teachers forget to show you there's a little more you can do with U sub. Do you want another U sub example before we?
Yeah.
All right, let's see. What do you got, Jeff? Here, I'll do two more. Yeah, sure, Jeff. There you go. How you guys like them? That looks so yummy. So yummy. So just imagine if the question was take the derivative of that function, that would so suck, yes? So this is a very interesting function. The integral is easier to do than the derivative. The derivative of this function would be product rule, chain rule, yes? Now, do you guys identify that if that wasn't there and that wasn't a fifth power, the answer would be tangent stuff, yes? So there's extra shit, and whenever there's like extra shit that's making it not a direct integral, that's very often U sub. Because I can rewrite the extra shit and wrap it into du. Do you guys see a function in there? Maybe it's stuck somewhere, whose derivative is in there also.
Yeah, x to the fifth minus 11.
Yeah. So I'm gonna let u equal what?
X to the fifth minus 11.
That's crazy. And what's du?
5x to the fourth secant squared dx.
No. There's u. There's u. What's du? Don't bring any
Minus-
other shit.
minus
There's u.
11x. Minus 11x.
No, we're not
Oh,
integrating.
nothing. Oh, nothing.
We're taking the derivative, yes?
Nothing.
There we go, I heard it. dx, yes, because the derivative of 11 goes to 0. Yes? You guys with me?
You would keep this.
When I decide what u is, du is just the derivative of that. You with me?
Oh, so everything
Does
else
this
is
say
not-
anything about secant or anything? No. You with me? The minute I let u equal something, I need to take its derivative. It doesn't matter what else is in the
So
integral.
if you have a function that's like insanely long or whatever, and u is only a specific part of the function, and the du would only
du would only be that, because
and everything else
you
would be
identify
outside.
what u is. Du is only the derivative of u. That's all it is.
Oh,
Okay.
makes more sense.
You guys with me? Okay. Now, one thing that you gotta be careful about is always easy to just agree with somebody doing something, right? What you really have to be latching on to is what made me decide to do this? What was it about the problem that made me think to try this? Because you're gonna have to figure it out yourself, yes? And of course, that's always the worst part. So, how do I rewrite this now?
Would it be secant?
Yeah, because what's this? What's that?
Du.
That's du. And then what's this?
U.
U. Is that an easy integral now? Yes. So what is it?
The antiderivative?
Yeah, what is the answer? What's the answer?
Tangent?
Tangent, yes. Plus c. And then what's the actual end? Why don't you circle this?
Because it just goes away. Because it's definite.
No. Why is this wrong if you circle it? It's not definite. It's
Or
indefinite.
indefinite.
It's indefinite totally. So you shouldn't get a number. You shouldn't be plugging stuff in. But why is this wrong if I circle it?
Because
If I ask you something about Fred, yeah, I'm like, hey, tell me about Fred. And you go, well, John's a nice guy. John's really. No, Fred.
Oh,
Tell me about
'cause
Fred.
you're not doing attributes.
What was the question about? What variable was the question interested in?
Not you. It was,
Doesn't give a shit about me or you. What's the question about?
X.
X. So if you circle this shit, that can't possibly be the answer to a question involving X. So what's the thing I forgot to do?
Tangent of x?
No, what was you? What was you?
X to the...
Yeah, just bring back what you was. Well, I didn't have to do that when I had a definite integral, because instead of bringing back X, what did we do instead? We changed the limits to match u. Now, maybe you understand why student Jeff, I thought to myself, I'm gonna get confused. So let me just never change the limit, just always bring X back. What I'm trying to get you to realize is, my teacher should have sat me down and said, listen man, I understand that, it's actually not a bad idea. Right? But don't do that shit. You need practice changing the limits. Just change the limits, trust me. Yes. Okay, maybe. Do you guys see the difference here? I had to bring x back because the answer's got to be a function of x, because it was a function of x to start with. If I have a definite integral and I change the limits, those numbers go in for you and I get my number. I would get the exact same answer if I brought this back in
So if there's.
and I put those numbers in. I get the exact same number.
So indefinite integral, solve for x. Definite integral you could substitute for u as long as you.
Yes. So you either have to bring x back at the end, that's what I do for indefinite, or you change the limits to match u and then you don't have to bring x back.
Okay.
Okay. How do you guys feel about use of now? It's always rocky getting into this, but you have to train your brain to know what to look for. So when I see a problem like this, I automatically see the fifth and fourth powers, and I think, oh shit, use of might work. What would make it not work is if this was 11x. Because then the derivative would have been 5x to the fourth minus 11, which is not what that is. And then I'm screwed. Literally, because then I actually wouldn't know how to do that problem either. I have an idea, but it would be disgusting. Okay. All right, maybe. I did say I was going to do 2, and I already forgot what the other one I wanted
have
to.
a-
Oh, I didn't remember, huh?
I have a random question.
What's
Is
that?
infinity a constant?
Okay, real quick. What is infinity? I mean, it's a good question because we've been working with infinity this whole semester. Go. When I say that sentence, I'm sort of being disingenuous, to be honest. I can't work with something that's not. Before I give the answer away, what is infinity?
Everything.
It is a concept, but I'm asking you what that concept is. It's an idea.
It's growing.
Numbers will continue to expand.
I like what you're saying.
Is it a function?
No. All right, I'll go with what you said because that's the closest I've heard. It's just a continuation. Infinity is a process. 1, 2, 3, 4, ... That's infinity. You guys understand? Infinity is not a number. It can't be. Right? Imagine the biggest number right now. What's the biggest number you think of? Okay, raise it to itself. Right? Biggest number I can think of is 15 trillion. Okay, raise it to the 15 trillionth power. Now we're talking stupid big, and that still is nowhere near infinity. What's infinity then? Keep going. That's what it is. That's why it's so weird. That's why I say you can't plug it in, because then you're claiming that it's a place. It's a thing I could pick up and put in. Like, no, you can't. As far as I know. I don't know. Maybe if we all. I don't know if you ever there's a movie called Powder where at the end it becomes pure energy. I'm like, he saw infinity. Alright. Kick-ass movie, by the way, called Powder. See it. It's cool. Okay. One more of these examples here. I'll give you one that's a little bit crooked. You'll see what I mean in a second. Okay, I think this should work. Yes, this should work, okay. Now, real quick, I like this example because can somebody identify there's something wrong for this to be like a normal straight up u sum? There's something wrong.
There's no derivative expression.
Oh, good, okay. So, some people say, oh, I see a third power in a square, so the derivative of cubed is squared. But see, this is the one that's stuck. If I let u equal x cubed and du is x squared stuff, I can't put this with that, because it's stuck. That's why we almost always let u equal the thing that's stuck. Because then everything else is not stuck, and then they can go with dx.
Are you going to say this one of those examples where x at a third would be u?
No. So, what does u have to be? X squared plus 1. What's du then?
2x.
2x.
Do it.
Do it dx. Yes?
2x dx.
I'm gonna get you guys to do that. Just in case you see a tutor, oh my god. Some of my colleagues have people solve for dx and do weird, that's the stupidest thing. Okay, sorry. There's no way I'm gonna keep people, you're gonna see it. So you kind of divide by 2 and you substitute. That's bullshit. I don't need that. So watch this. What do I need? So this is going to be u eventually, yes? So that part's easy. What do I need to go with dx? No. What do I need to go with dx to make du? 2x, yes? Do I have like an x? I have 3 of them, yes?
Yeah.
So here, I'm gonna do this. I'm gonna put x squared times x. I need there to be a 2 here, yes? Don't I need there to be a 2 here?
Yeah.
So I'm gonna put a 1/2. Now, real quick, does everybody agree with me that I just wrote the same integral again?
Yeah.
Right? 1/2 of 2 is 1, x squared times x is x cubed. It's the same stupid integral, I just kind of reorganized stuff. Can I find du now?
Yeah.
Yes, right here, this is du. What's this?
U.
Yeah, so the inside's u, so that's the square root of u. I'm gonna write as u to the 1/2. I got a 1/2 here, and then this guy, that guy. Look at him. Look at him, he knows what he did. What the shit's wrong with you? Why are you there for? I don't want him there, right? What's wrong with him being there?
He's annoying.
Why? I want an integral that only has
U.
u in it, so if he's there, zip. We already did something earlier. Do I have a relationship between x squared and u somewhere? Yeah. So what is x squared?
X squared.
Don't think too much.
U minus 1.
U minus 1. So wherever I see an x squared, I could put.
U minus 1. Okay, just on the test, the problem's not going to be like this. So,
I'm telling you, this one is a freaky one.
right. So there's
That I just want to show you right now the flexibility. Normally, what I would give you on a quiz or a test, especially in the summer calc class, it's going to be a more straightforward one.
Okay, cool.
But I have got to lay the groundwork now to show you that there's more you can do with USEP. Because when you go to Calc 2, you're going to jump right into the next integration process. And I think I already told you it's called by parts. And your teacher, like I try to review USEP, but teachers normally try to get right into the new stuff. So you got to kind of know all the ins and outs of USEP. Do I now have an integral that only has u in it? Is anyone perturbed?
Yeah.
Real quick, could I distribute this here?
Yeah. No.
Please say no.
No.
Okay. Could I distribute this here?
Yeah.
Of course I could. So there you go. So now that's not that bad. Distribute to the u to the 1/2. You get a couple of powers. Yes, u to the power. That's an easy ass integral to do. Yes.
So essentially now, since it's not definite integral, you just replace it with the x's.
No, we haven't integrated yet. We haven't done the basic thing it's asking me to do. It wants me to integrate. Have we integrated yet? No. So if I distribute, I get u to the 3/2 minus u to the 1/2. What's the integral of u to the 3/2?
Huh?
You can do it. What's the integral of u? Is everybody cool with that? U to the 1/2 times u to the first is u to the 3/2. U to the 1/2 times 1 is u to the 1/2. What's the integral of u to the 3/2? U to the 5/2. So you just put the reciprocal out front. Integral of u to the 1/2.
It's just 2. 1/3 over 2.
Put the reciprocal out front. Yes?
Yeah.
Then distribute the 1/2 and replace u with what it was. Okay. Freaky. But do you see how you want to start looking at an integral as, I have 3 x's I can play with. I have an x squared plus 1 that could be a u. You start looking at the elements of your integral as stuff you can move around and play with. And you're not used to looking. X cubed is x times x times x. So if I need an x, I can just take one of them and use it. And then I'm left with these. Damn it! Oh, but I can replace them. Okay. Okay, maybe.
No, this is
Now, just to make sure you all understood the question that was just asked of me, I might give this to you in a bonus. This is a little beyond basic use of, but I have got to show this to you because this is going to happen to you in Calc 2. And you might get a teacher that doesn't review use so much. Okay.
He's gonna give this as a bonus. So,
Yeah, this level of problem where you have this freaky little thing you have to do, I would probably give it to you as a bonus. Yeah. Yes. Oh, it was a 3/2. To integrate, I add 1 to the power. The shortcut is 3 plus 2 over 2. And then I divide by the new power, so I multiply by the reciprocal. Yes. So integrating stuff to a fractional power is easy as shit. You just add the top to the bottom, put it back over the bottom, flip what you just wrote, put it out front. Because that's the rule. Maybe. Okay. Some of you guys look like this. Just tell me, just make this over now, John. Okay. So. We have got to spend the rest of the time today on getting into chapter 6. And the way this is gonna work, I've got so many handouts, it's stupid. I want to start with this one. This is gonna be one of these little group exploration projects. Can you guys all handle getting together with one or two other people? Most of you guys have no problem with that. If everybody please find one or two
That's
other
what you
people.
want to do? No?
to work with.
I thought you wanted to go this way, I was
Yes, no. They give you, okay. Am I recording? Oh, yes. Thank God.
I don't know, bro. It's okay.
Shut up with you.
Here.
Yeah, shut up with you.
Would it not work if I text?
Look, cause look, graph it. You get pointer intersection at -1 and a border intersection at y equals. That's
So
it.
what's needed is to if you ever find us a value that would make the y like 0, that's one.
Oh, okay.
But technically,
Right. It has to be equal to each other. What's -1 plus 1? 1. Okay, now -2 plus
-1 plus 1.
-2 minus 1 is 1. Now what the fuck you doing?
I don't know, but
He said what he said he's gonna do is so clearly if he said he's gonna do it, it's gonna be
yeah.
Oh, bro, I'll tell you this. Once I finish calculus, inshallah, I'm never gonna have two more quiz. I'm telling you, 4 months, 4
When are you taking calculus too?
it's one execute.
This month?
You just do this. Because they have some sessions.
Execute divided by
Come
x.
with this extra. So like
So you get that,
Huh?
yes, look at this. Come with it.
and then you factor. That's just the first.
Chocolate that.
Like an x. Yeah, do it. Do it.
I'll go to, by the time it's August and September.
Did you already sign up?
Yeah.
Yeah, for calculus too. Yeah, for the in the fall.
Yeah.
For who? No, because he's gonna fuck up our schedule. He's going from 7:15 to 9 something. Actually, so we can't take Jet? No, I wanted to do it. Unless you want to talk to your counselor and get like present exempt on every single one. Wait, from 7 to 9? It's 7 a.m. to 9 something. Oh, I'll do that. You'll do that? Yeah. I don't care, I'll do it. I'll just wake up, I'll just have to wake up
We
early.
factor out the hours reduction.
No, but what about do you have like a 2 through 9? What do you mean 2 through 9? You mean,
Yeah.
I mean 2 through 7? I don't know, I'll change my schedule. I'll change my schedule so I'll skip non class. I'll TA for, because I promised Rodriguez I'll TA for one this year. Because I want to have, I'm not taking some random teacher. He's actually such a good teacher.
Yeah.
Okay, then I'm changing my schedule on.
If you took calculus 2 like if it was another month, you would have done it.
Yeah.
He was nice to be
Yeah.
It's phenomenal. You also you don't get punished.
You don't get screwed over, yeah. Like, kind of calculus too, if I have like a horrible teacher with like horrible grading.
You also
Yes, exactly.
I took math too with like one years and definitely college.
Yeah.
40% of the class.
Yeah, whatever the hands
It's not
like.
easy.
Yeah, just say equal to 0.
I
Whatever.
promise you, when I went to pre-cal, the guy who was him, I got an minus.
Yeah.
The teacher was a fucking
Yes.
shitty.
Plus minus.
That's the thing.
Wait, what is math to about?
It's literally, bro, it's literally just like absolute values.
How does 40%
Yes.
less than
The teacher, that's
teacher matters a lot. Yeah.
Because he wouldn't allow calculating. So, and he'll give you like, what's 3 squared, like 3 to the cube power
Yeah.
plus 5 to this, like 75.
Yeah.
And you're doing it touches it. Fucking stupid is that?
5 to the what?
75.
7 powers?
And that's the thing, you know, do absolute value, like, off the top of his head.
Listen, I could try.
Square root of 3.
Now I gotta try.
Square root of 3 goes.
Same answer you get. Don't worry about it.
It's actually
25, but it's gonna be hard to do in my head. I don't want to. I'll give you an estimate. How's that?
Oh.
was it 5 to the 7th? Yeah.
0, 0, 0, 0. What is that?
0, 1, yeah.
0, 0, 0. 60,000. So that would be. Wait a minute. Wait. 60,000.
You're hard.
2,500. Wait. 2,500. I don't know. I'd say like 67,000 something.
78,000.
What is it? 78,000. Yeah.
Wait, what about 5 to the power of 6?
I couldn't keep it all in my head. I was trying to.
5 to the power. Wait, just 5 to the
So in
power
my
of
head, I was
6.
doing this. 625 is 5 to the 4th power. 125 is 5 cubed. So if I multiply those, I get 5 to the 7th. 625 times 125 is 600 plus 25 times 100 plus 25, and then you foil. But I kept losing where I was.
Yeah.
The fact that he
Wait, you teach calculus too, right?
Huh?
You teach calculus too?
Oh, I see calculus too. Yeah.
Yeah.
I was like, I didn't teach you
In
calculus.
August, right?
Yeah.
Yeah, in the fall.
Morning or after? Or
I think that's. I have one class that starts at 7:15.
7,
I
and
can't
then
remember if
it
it's
ends
that
at
one.
9:30, right?
Is it a calculus? Yeah.
You don't teach calculus
I'll be,
too? Like,
I'll be surprised if I end up with a lot of people in there. Huh?
you don't teach calculus too, like, after like 2 o'clock?
I only teach one class of calculus.
They took off math 176 now. They don't pre-calc it. Did they take it out?
Not yet. They gave us 2 more years, and we created another course that would take its place if they do kill it. Because we almost all of us feel like they're probably going to kill it.
Why? But why would you take away pre-calc?
Because it's keeping people from their degrees. Us evil man.
How's your art? If I can get a. How's your art? I told you I got dropped. Teacher dropped. For no fucking reason. You probably weren't doing that. No, listen. I emailed her. She ghosted me.
All right, guys, I'm going to catch up to you a little more. So if I factor this, it'll be x times x squared minus 1, which factors like this, yes? And then you get x equals 0, 1, negative 1.
Yeah.
Now, real quick, some of you guys got here, and then you divided by x. And then you got x equal plus or minus 1. Do you see how you lost 0? Because when you divide by x, you're assuming it can't be 0. So you lose answers if you divide by something that could be 0. Now, to be honest with you, this is what I used to do, and I just would put x equals 0 as an answer. And then I would just get the other ones as I went. But don't do this shit, okay? Don't do that. Now, listen. That leads to 3 points. That what is true about, if I input these, what's true about those 3 points?
So the intersection of the two functions.
All 3 of those points are on both of these functions, yes? So let's see, when I plug a 0 in, I get a 1 out. When I plug a negative 1 in, I get a 0 out. And when I plug a 1 in, I get a 2 out. Look at me go. Yes? One of the functions is a straight line. Whee. Okay, he's mostly straight. The other function is what kind of a function?
Cubic.
Cubish. And you know, they kind of bend, they have a concave down and then they have a concave up. So if you don't know what that means, that actually means it's going to be above and below. But if you just plug a negative 0.5 in, negative 0.5 cubed is negative 1/8 plus 1 is like 7/8. So it's going to be just below 1. I don't know. It's going to be around here somewhere. So I'm going to have a cubish thing. It's going to go like that. Oh, I should have done it as a different color, but everybody's going to be fine, Jeff. Okay. So did we just capture an area? In fact, we captured like 2 areas, didn't we? You guys see that? So the question said, find the area between these functions in the first quadrant. I want to find this area here, the area of that banana. Does everybody see the banana? For some reason, there's a decent number of bananas that show up in this chapter. So I didn't ask you for that, did I? But that's what this is leading up to. Because can somebody tell me just what would this mean?
The area of x plus 1 from
Yes, so the area between the line and the x-axis, yes? So that would be this area here, yes? Is everybody with me?
Yeah.
Because it's the integral from 0 to 1. So that integral means area. Area under x plus 1 from 0 to 1. What would this one be?
The area of
X cubed plus 1 from 0.
Yeah, the area under this. So that would just be this area here. So if I want just the area of the banana, what would I do?
You would subtract them.
Yeah, I call this a cookie cutter problem. So if this is my sheet of cookie dough, and I would just cut this out. I would subtract
So
this from this.
you integrate the function first, and then plug in the numbers.
No. You ready? Here's what I would do. I want to find the area under this and subtract the area under this. So I end up doing the integral of the top function minus the bottom function. So if I ever want to find the area between two functions, an immediate concern of yours is, well, number one, where do they meet? And number two, who's on top? Because that guy's got to go first, or else I get negative area. Now, in these problems, this is physical area that can't come out negative. This is physical area now, yes? Before we had like profit, and unfortunately profit could be negative, so I could get negative area. But this is actually physical area, got to be positive. That's why the bigger unit's got to be first, and then you subtract the smaller one. Okay. Is everybody semi with me?
Yeah.
Compared to some shit we've done, this is not that bad. So if I do this, what could I do first inside here?
Find
Integrate the
No, come on. Just simplify before I do any calculus, yes? What happens to the ones?
cancel.
Thank you. Okay. Now just integrate that, yes? Here's something else I find interesting about students is once you get something set up, it doesn't matter where it came from, you just look at that. What do? I subtract the ones, they cancel. It doesn't matter where they came from. It doesn't matter that's a banana, it doesn't matter anything.
So then it'd be
What's the integral of x?
x squared over 2.
1/2.
Good, I like it. Either way, I don't care. What's the integral of x to the third?
1/3 x cubed.
Careful. No, it's already x cubed.
1/4 x cubed.
And I want to evaluate that from
0 to 1.
0 to 1. So when I plug a 1 in, 1/2 minus 1/4, and when I plug a 0 in, I just happen to get 0 minus 0. Is that cool? So I get 2/4 minus 1/4 is 1/4.
So the area is 1/4.
Area is 1/4. Okay. So this little area here is 1/4. Okay. How's everybody doing? You guys all right? Okay. Not too bad compared to some other stuff. This is really silly, to be honest. I love this is section 6.1, but it's kind of like, you know those integrals you've been making? You can just subtract them and get areas between things. That's all it says. Sorry? This is 6.1. Now, here's the other thing that 6.1 introduces that is going to show up in the rest of chapter 6. Bless you. Is basically turning your world around. So let's do this one together. So what is automatically different with what we're working with here?
The x's and y's are like.
Yeah, I got a function of y. So, which means a parabola normally looks like this. Now they're going to look like this. Yes, unless they open down, in which case it's going to look like that. So it's, essentially, if I just switch x and y, I just rotate my graph. Okay, like that, maybe. The algebra doesn't change. How do I find where those two
Put it equal to
meet?
each other.
Yeah. So I take this guy and I set him equal to the other dude. How do I solve this crazy ass thing?
You just add and subtract
Plus
equal
10
terms.
adds negative.
Hell no. Hell no. Why not? Because it's not equal to 0 yet.
Well, just move
Minus.
the y.
Yeah.
The y.
Add y squared, yes. Add y squared. And also also?
Why would you add?
Subtract 6y.
Why would you add? Oh, okay.
What's negative 6y minus 6y?
12y.
Minus 12y.
Plus 10.
Alright, let me stop for a minute. Somebody with me?
No.
This is a really easy place for your brain to go, oh, the 6y's cancel, but of course they don't. They increase themselves. What do I do now?
Take out a
Hell yeah, I'll divide by 2. I can divide because that 0 just eats it up, right? Divide, 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 divide. And that's easy to factor, yes?
2. Yeah. 2 and 3.
Yeah, y minus 2, y minus 3. No, it isn't. Look at me agreeing with you before I even think.
Is it not?
What do I need the two numbers to do?
Add up
Multiply to be
5.
5.
Add up.
Add up to be negative 6.
5 and 1.
Yeah, there you go. Don't worry, I was ready to go along with.
And I failed, man.
Alright, but I already got my degree. Can't take it. So, same idea, yes? The function changed a little bit, they factored it a different way, but who cares? It's the same idea. Set them equal to each other, get it equal to 0, right? If the powers are different.
So x would equal 5 and
At y.
1.
Can anybody help me figure out what points they meet at?
5 and 1.
What points do they meet at? These are the y values, yes?
Now you plug in.
Oh, you just plug it back in?
Yeah. Doesn't matter which one I plug it into.
No.
Because we just figured out that's where they have the same outputs, right? That's where they intersect. So I'm going to use this one because there's less going on with him. If I plug a 5 in, I get negative 25 plus 30.
Negative 5. Positive.
Negative 25 plus
Positive.
30.
It should be positive.
Yeah. So that one you can't go wrong with. Let's see if everybody sets up the next one correctly. If you plug a 1 in for y, what do you get?
Negative 1.
Negative 1 plus
6.
is?
5.
So what point is that?
5. Oh, it's the same point.
No.
Sorry,
What did we just plug in?
Sorry, 1 and 1.
5 and 1.
There it is. It's 5, 1. Now real quick, I need you, this is unfortunate that these were both 5. We plugged a 5 in for y and we got a 5 out for x. We plugged a 1 in for y and we got a 5 out for x. Yes? Is everybody with me?
So this is not a function. Actually, wait.
Technically, no. This is not a function of x. This is a function of y. If I just turn, so you'll see, I'll do exactly what I just did. I'll just do it when we get it graphed. And then we turn it, we're like, oh shit, it's just a normal thing.
One would be a positive parabola, and the other one would be negative, like a flipped parabola.
Yeah, one is going to go that way, the other is going to go that way.
Oh, because it's a y.
Oh, wait. Is
Yeah.
Do they touch the vertex?
Sorry?
Do they touch the vertex?
We'll find out. I don't know. Okay. So we know they meet at 5, 5, and 5, 1. So I'm going to plot 5, 5. There's 5, 5. Yes? Is that cool?
I can't see.
Oh, let me zoom out a little bit. So there's 5, and there's 5. 5, 5, and 5, 1. That's where they meet. Now, let me see if you guys get what's going on. So one of them is going to open this way, and the other one's going to open that way.
Oh.
Yes?
Yeah.
If I could just figure out one more thing about them,
If you find the vertex.
if I can find the vertex, yes.
Rise over run.
B
No,
line B
no.
squared.
All right, everybody, just take a beat. Take a beat. So one of these parabolas is opening this way, and one of them is opening the other way. Yes. So like, I have a parabola here, and then I have another parabola there, and so I'm going to have this area in the middle that they catch. Yes.
Oh, just plug in. Find what's in the middle and then plug in that number.
Yeah. The shortcut to find the vertex. In fact, let me see. Let me go ahead and turn this way. What y value has to be the vertex, or
3.
why?
Because it's right.
It's in between, yes? What's true about any parabola, I don't care how it opens, it's got to be symmetric. Boogie, woogie, woogie. So if I got a 5 and I got a 1, the vertex must be a 3. So if, I really want you guys with me, listen. I know this is a little evil, but what is pre-calc supposed to put you through? Graphing hell. You're supposed to come into calculus, able to make little sketches of any damn thing because you've gone through graphing hell. Yes?
So if I just knew the vertex, I could graph both of these parabolas, because I already have like 2 points that each one goes through. I just need to know where the vertex is. If I have this and this, the vertex is in the middle, 3. So if I plug y equals 3 in, I'll get the vertex point for each. So let's look at this dude.
So -9.
If I plug in a 3, what do I get? Yeah, well, careful. What do I get when I plug a 3 in?
Positive.
Positive.
9. So this will be, what did I just say? Yeah, this will be, what point will this be?
3 and
X is
9.
9 when y is 3. So one parabola looks like this. Just go a little bit past. Yes? Pretend like that's good. It's almost good. And then the other parabola, how do I figure out his
Same thing.
vertex?
Just plug in a 3 for the
Plug in a 3 into the other dude. So it'll be x equals 9 minus 18 plus 10.
So 19. That's how you
19 minus 18 is
measure
19 minus 18 is
Oh, 19
It's
minus
1.
1. 9 plus 10. 9 plus 10 is 19 minus 18 is 1. Or 9 minus 18 is negative 9 plus 10 is 1. Yes? Okay. You guys with me?
Yeah.
What point did I just uncover as the vertex?
1,
1 comma 3, yes. I plugged a 3 in for y, and I got a 1 out for x. Now, we're so used to the numbers we plug in being the first part of the point. You got to now expand your idea and go, no, what I just plugged in was the y. That's the second part of the point. Okay, so 1, 3 is here. And this parabola opens that way. So now the area I want is this area here. Basically the area of Stewie's head. So if I turn it like this, that looks more like what we're used to. This looks like the UFO from that movie.
Stewie from
Mhm. What's up?
Stewie from Family Guy.
Well, that's what this is Stewie. That's what I just said. Finding the area of Stewie's head. Okay. Let me stop for a minute. Everything, when I have x as a function of y, everything's just kind of termed. So you could literally do this. So what would the integral from 1 to 5 represent of this? It would represent the area between the y-axis and that. What would the integral of 1 to 5 of this one be? The area. So I just subtract those two. So which one is on top? Which one is bigger?
The one on the left.
Look at it.
Oh.
Which one is on top, literally?
The one on the right.
This one. Yes? No question about it. What are the outputs for an input of y? What's the output? X, correct? So which one has bigger x's?
The one.
This one. This one. Which one was this one? I should have.
That one was the one on the left side.
Yeah, this was this one. Yes.
Mhm.
So that I would put first, and I think, yeah, that would be what I would call f of y, and this is the bottom one. This is what I call g of y. It's the same stupid idea we just did. It's just turned. Because now my inputs are y's and my outputs are x's, so I could actually look at it like this. Now, one thing that's weird is the y-axis, of course, gets bigger this way. Well, you just got to be a little careful about it. Okay. So what are my A and B going to be? In fact, what do A and B have to represent for this? Right, there's so many things happening. My functions are functions of what variable? What's my input for both of them?
Y.
Y. Good, right? So my integral has to be dy, because these are both functions of y. So what do these numbers have to represent?
The Y.
What y is doing, yes? And of course, what's y going from to?
From
As I look at this area, what is y going from?
From 1
to.
to 5.
From 1 to 5, yeah, which is the intersection we found earlier, yes? So this will be the integral, y going from 1 to 5. Top function is this guy, minus the bottom function is this guy.
So everything we just did, all the math we just did is exactly the same as the math on the other side. It's just everything's been turned around.
So you distribute the negative
Can
sign.
you?
What?
So you distribute the negative sign. With the
Yeah, I
subtraction.
told now you just no. This is the easy stuff. This is where you gotta release the work you did to get here. Just forget it. Now you got this integral. Look at this integral. It's an integral of a polynomial. I don't give a shit there's y's in there. I don't care where it came from. I don't care if it's Stewie or freaking UFO. I can just put my like terms together, integrate power rules. Do you guys see what I'm saying? But I think sometimes students will look at a problem like this, and because of where it came from, they're like, oh, this is hard. No, it's the same stupid shit. It's a nice, easy integral. This is an easy integral. It's just weird where it came from. So negative y squared minus y squared, 6y minus negative 6y, negative 10, and now you can integrate that.
Negative 2/3 y.
Yeah, no, go ahead. I almost don't care what the answer is now, because you just apply the idea and then throw the numbers in, yes. Which to me is very boring, but it's okay. We're done applying ideas, now we're just plugging shit in. What is the integral of this? You started telling me it's 2/3 y cubed plus, this becomes nice, yes? The way I look at this is I want a factor of 2 to come up, so then what's left?
6 y.
And of course this is just gonna pick up, what's the interval of negative 10?
Negative 10 y.
And I wanna evaluate from 1 to 5, and you know, I really could barely care. You throw a 5 in, you throw a 1 in, you take the difference. Are you guys at all with me? Yes? You guys okay? Do you see why I don't care about it? Because we gotta all do that shit. You can even plug in your calculator, I don't care. The interesting stuff is done when we get to this point. Okay. Real quick, actually, is anybody actually trying to figure that out? Or have you all like just heard me say that and said, oh yeah, he doesn't even care?
Yeah, it's
So real quick, if I want to visually try to estimate this, I would try to make a rectangle that kind of goes out a little bit so it makes up for what it misses. So maybe this, let's see, I just drew it. So this is, hold on, just 6 times, what would this, oh yeah, you've drawn this horribly, Jeff. 6 times 4.5 is 27. What does this actually come out to be? Did I do that wrong? Let's see, 6 times 3.5. Hold on. Is 3 times 7 is 21. So what does this actually come out to be? Let's see. Negative 250 thirds plus 150 minus 50 minus negative 2/3 plus 6 minus 10. Oh my God. So whatever the shit all that is, let's see. Negative 250 plus 2/3 is negative 248, which is not divisible by 3. So I get 100. I get 104 minus 248 thirds, and that's roughly 80, almost 83, which is almost 21. Holy shit! Sorry. That whole last part was just, I'm sorry, it was just for me. I'm sorry, but you guys with me? I'm just trying to figure out what this is in my head, right? Did anyone do this? Get like about 21 point something?
yeah.
What'd you get?
I got 21.
Or what'd you get?
2 point.
No. That didn't sound right. Yeah, 21 point.
Oh yeah.
21 and 1/3.
And 1/3? Gotcha. So my estimate was pretty, by the way, real quick, this is kind of, do you guys see how I drew that rectangle to have a little overlap to make up for the part I missed? So it's, if I just need a really rough estimate of an area, I can always draw an image where I lose some, but I gain more, right? We know this from the over and underestimate stuff. So I drew a really quick rough rectangle that kind of overwent and underwent, and the area I got from it was 21. And the actual answer came, I just got lucky that I drew a decent rectangle, but the area was just a little more than 21. Okay, maybe, I don't know if you guys remember. Okay. How do you feel about this idea? So if I say find the area bounded by these functions, see where they intersect, figure out which one's bigger, which one's smaller, subtract it in the right order, integrate that, blah, blah, blah. It literally is just taking a full area minus the bottom area to get the area in the middle. It's just a very physical answer. Oh yeah, you guys ready for a break? I understand. Some of you guys are like, come back at 10 after. Come back at 10 after. Dad, come in. There. Okay. So what bums me out about, well, shit, where's everybody? I said 12:10, right? Okay. All right, guys. So, what bums me out about something one of my students gave me a while back. There's this type of decoration that we had when I was young, and somehow this student found one for me, and this is like 12 years ago. I have no idea where I put it, but it's a semicircle. Yes, it's a semicircle. You with me? But you would open it, and it would make a big sphere, and then you could like hang it up. I don't know if you guys have ever seen, it would be like this poofy sphere. So it's a semicircular region, but then you just open it, and it would make a sphere. And the crazy thing is, it was so perfect for the sections we're about to get into, because we're basically gonna mathematically do exactly that. We're gonna have a region, and we're gonna rotate it, and then we're gonna find its volume. Which sounds very exciting. That's how we all do it. Thank the gods, I do have a semi-decent app that I found. It's through GeoGebra, which is a very nifty little website. To try to, instead of me trying to draw things, because I can barely draw 2D. One really nice thing I want to let you know, if you're a really bad drawer like me, you do not need to draw any 3D for these problems. I am going to try to draw some 3D just so you can kind of get an idea, and I am going to rely a lot on the computer to draw 3D because you can do it better than me. You guys can, but to do a problem, I'm going to show you how if you do a problem, you don't need to go to 3D, which is really good for people like me. You can't draw or shit. Okay. So here's the basic idea for 6.2 and 6.3. I have a region, some function I'm given, yes? And what we want to do with that is we want to rotate it. Now, I could rotate it around any line. And I could even rotate it around the diagonal line, but that's beyond the scope of our class. So we're going to rotate it around, like I could rotate it around the x-axis. Yes, I could rotate it around the y-axis. It would make this really weird looking bunt cake pan. You guys know what a bunt cake pan looks like? Anybody can describe to me the main feature of a bunt cake pan? Yes, there's a hollow thing in the middle, yes? So do you see how there's a hollow space here? So if I rotated this region, rotated it around the axis, there would be this hollow thing in the inside. You guys kind of follow what I'm saying? A little bit, okay. If I rotate this around the x-axis, will it have a hollow region? No, and here's what I like to say. If your region is hugging the axis of rotation, there won't be any hollow place. So if I rotate around the y-axis, is my region hugging this? No, so there's going to be a hollow space. So pretty roughly with me now. Just let go right now of what your work is going to look like. Just let's talk about the ideas, right? The work is not going to look as hard as it might seem it's going to from what I'm saying. But this is the idea behind what we're going to do. Okay, so let me immediately go to a computer rendition. Dear God, because if I try to draw any more, we might all go insane. Let me see if I can't zoom into this. Yay, it works like that, thank God. So what's drawn up here for us? Gosh, can I make this ad go away? Is that this there for decoration?
You can close on it.
It says I can. Let me see. And then it says, no.
Right.
Maybe scroll down because of the.
All right, screw that. Here, there we go. Okay, that's a little bit better. Will you close now? Screw you. Okay. Oh boy, it's the website's on drugs. I think it's having a little psychedelic moment. Look at that. Sorry. Okay. All right. Stupid ads messing with me. So this is a graph of the square root of x. Is it square root of x or I can't remember now? We're at 4 times the square root of x. That makes sense because it's 4. It's kind of like 4 times the normal square root. You guys with me? So it's a nice normal 4 times the square root is going to be taller than a normal square root. Yes? Is everybody with me? And I kind of stopped at 10. So this is, where do they say that? It doesn't say that. Okay, it's okay. So here is the shape. Here's the boundary that I want to rotate. I would say it's the area captured in the first quadrant between 4 square root of x and x equals 10. So if you graph 4 square root of x, you graph x equals 10, you graph the x-axis, that's the region you just caught. That's what I want to rotate. Yes? You guys still with me? Okay. In fact, can I borrow your notebook for a second? This might be the closest thing I can get to what I'm trying to say. So is there any, that's a rectangle, yes? I could graph a rectangle. And then if I rotate the rectangle, it would carve out a cylinder. You guys see, if I rotate this and there was volume left behind it, it would carve out a cylinder. Yes? Okay, that's effectively what we're doing. So, sorry, I almost returned it to you in the right space. I'll only do this for myself. Okay. So, people at home, you still see it good. Okay. Now watch this. This is kind of cool. Let me see if I remember how to do this. Oh, that's right. So what I'm going to do is I'm going to step out of 2D for a second. There. Now I'm in 3D. Yes? So it's like the XY plane is the ground, and we're, of course, in 3 dimensions, thank the gods. Okay. Not much room for lungs if you're in 2D. So here's what I'm going to do. I am going to rotate that region around the x-axis. Bless you. You guys kind of with me?
Yeah.
That kind of reminds me of like a convertible. Yes? But the difference with the convertible is that goes all the way around. So I can still see my original 4 square root of x there, yes? It's just been kind of repeated for 2 pi radians. It's just been repeated. So everybody kind of with the, this is silly. That by itself is a very straightforward idea. Obviously, as straightforward of an idea as that is, capturing what I just did mathematically, not going to be completely straightforward. Yes, it's easy to go, I'd move it, look at me. But then to do that mathematically, can somebody help me out? If I slice that anywhere perpendicular to the x-axis, what kind of a cross area will I get? Nope. So real quick. Here. I really want this idea to make nothing but sense. So let me come back to here. Let me turn you off. Okay, so if I took this point, yes, and I rotate it around the x-axis. This distance, does it change as I do? Okay, so this is the center of rotation. Any specific point, if I rotate it, it's going to make what shape? Because they're all going to be equidistant from its center, yes? If I take any shape and I rotate it, any cross section is going to be circular. Which the funkier the function is, the less it is that you might believe that. But if you just go back and go, if I take any single point and I rotate it, of course that's going to make a circle. In fact, if I do this again, boop, and I just look at it dead on, what shape is that? Freaking circle, yes. And of course, if I just move in a bit, like scan it like a CAT scan or something, what is it, MRI maybe? If I just sliced it further back, it'd be a smaller circle, yes? Now real quick, can somebody tell me, based on the function itself, oh shit, we're all gonna be okay. God. Okay. It's not the easiest thing in the world to control. Okay, there we go. Why does it make sense that as I move in, the radius gets smaller? Because what controls the radius? The function value. That feels a little bit like the height of the rectangle being controlled. Okay, believe it or not, rectangle is going to come back in a nice way in a bit. So listen, this is kind of silly. I need you to really get this. If I do rotate this region, pop, and I want to get the volume of this total region, I need you to see how stupid this is. Do you all agree that this circle has an area?
You're talking about the region that's...
I want to get the volume of the pink. I want the volume of this bowl. Yes.
The whole bowl?
Yes. In fact, let me try see if I can do it like this. Is that better?
So you want the volume of the entire thing?
I want the volume of this bowl, the volume of this bump, the volume of this thing. Okay. Do you all agree there's a circle here?
Yeah.
That's crazy, Jeff. Yes. If I move one little step in and I cut again, isn't that another circle? So how do I get the complete volume of this then? I just take each circle area and I add them. Now how many circles are there? So I want an infinite sum of circle areas. Do I have a process that does that?
Yeah.
We call it what?
Summation.
No, you might call it integration. Anyways, so I could write it like limit single to infinity, but I want it to have the radius is repeated. There's an infinite number of radiuses that all lead to circles and blah blah blah. But I could just go straight to the interval. Okay, so everybody semi-see the physical reality of this kind of problem and how it inherently wants calculus. There's an infinite number of slices I can make. And each slice has a different area. And if I just add those all up, I get the volume of that. Okay. Infinite circles to add. They all have area. I want to add them all up. Oh, that's integration. That's what integrals do. So, let's do this. Here, instead of this funky region I just drew, let's do the one we just talked about. I don't know why it stopped at 10. Let's be better than that. Let's stop at 16. Can somebody tell me what this would be? So my function is 4 square root of x. So what would this output be for an input of 16?
4 times 16.
16, okay. You guys all with me? And let's say I want to rotate it. So what I always do for myself, because some problems are going to want you to rotate around the x-axis, some are going to want you to rotate around the y-axis. I just always draw myself a little thing to remind myself where the axis of rotation is. Something that's going to be a theme across section 6.2 and 6.3 is locating an arbitrary place. We've done that before. So everybody just pick a spot between 0 and 16 on the x-axis. Pick a spot. I'm going to pick right here. I'm going to do the beginning of this problem. In fact, I'll try to see if I can't just get away with not drawing any 3D for this, because me drawing 3D might physically hurt somebody. Can you draw in the radius for this? So just imagine, I'm gonna rotate this around here. I'm gonna rotate, so I'm kind of focusing on the point. So what would the radius be? Just, yeah, well, how would I draw the radius in? And where would I end? At the function, yes? All right, this is really silly what I'm saying, but where's my axis of rotation? The x-axis. Where's my function? There. How do I draw in a radius? Start at the center, which is the axis of rotation, the edge. I just drew in an arbitrary radius. Can somebody tell me how long that is?
X or Y.
Be better.
R.
Which I told you, so be very specific. How long is it?
4 squared.
4 squared of x. 4 squared, no shot. So this is some arbitrary location on my x-axis, correct? It could have been here. I just kind of drew it somewhere just to give myself a visual anchor. It's the radius here is just going to be 4 squared of x. Can somebody now tell me what's the area of the circle that I would generate if I did rotate this? Why do I not have to draw 3D here? Because what's the only thing I need to know to get the area of the circle?
The formula.
No, what's the only thing I need? The radius. Do I know the radius?
Yeah.
Yes. What's that the radius for? Any circle, because it's x. So where could x be? X could be 16, x could be 8, x could be 1. So what is the area of any of these cross-sectional circles?
16x.
How'd you get that? You get, so it's pi times the radius squared, right? So then you get 4 squared is 16. Square root of x squared is x, and then you get pi sitting there, yes? So what did I just write again?
The area
Of what?
of the circle.
Of any cross-sectional circle that we make, if we do rotate this. So you guys still have in your head the Pepto-Bismol pink bowl that was made?
Yeah.
So we just took a slice at some arbitrary place and we got the area of the face of that circle that we would get. Yes? And what do I want to do with this now? Integrate. Now, here's what's missing. So I want to take one more step. How do I get to my next input? How do I get to my next circle that I want to add? Don't I step a little bit? How much do I step?
dx.
Let me see if I can represent this. This is x. This step is dx. So, the reality of this is, what I'm really doing, let me see if you guys are really cool with this. So, let me draw this circle that I would get. Do I dare try? Sure, Jeff. Are you okay? Yes. Don't draw this. But here is, for me, that's pretty good. So that's the circle I get if I rotate that one point. Yes? You guys with me?
Yeah.
So I'm going to kind of draw that here. So this is the radius. And if I move dx, I actually make a little, like, coin. Yes? So this height is dx. Do you guys know what the volume of that little element of area is?
Yeah, the cylinder.
Yeah, totally. So it's going to be pi r squared times the height. So it's going to be, we already did pi r squared. And what's the height in this case?
Yeah.
Dx. And that is an element of area. An element of area is given by this. Let me stop for a minute. I kind of like this better. I always teach this a little bit different. Is everybody with me? So, like, do you all understand that this is one element of area? Because to get the whole area, I have to get all the little elements of area and then add them together. So then what I want to do is I want to take all of these and I want to add them. And what's the only thing I'm missing?
So you want to add what?
About.
What's dA? That's like one slice. How do I get the whole volume? I add all all of those together. So I add all of these. Why do I have to use this symbol? Because how many of these are there? Infinite. And that's an infinite sum. What's the only thing that's missing for me to get the actual answer?
16x. I don't know.
Well, that's in there.
About.
Oh, radius?
Yeah. Where am I going from to? Now, real quick, stop. What variable is the integral controlled by?
X.
So then what is x over this region? What is x doing? Going from
0 to 16.
0 to 16. Okay. This is trippy. Was that difficult? Was any piece of that difficult? We all know the area of circles. If I rotate something at any specific place, we'll make a circle, no matter how freaky the whole thing looks. If I look at a vase, I don't care what shape it is, any cross section is going to be circular. Okay, maybe. Well, it depends on how they make the vase, but if they rotate it, yes, okay. I have just written a one-dimensional integral. Why is it one-dimensional? Because how many variables? One. But what does this represent? Volume.
Oh, so now we do the same thing.
Now you just integrate the dumb thing, right? By the way, there's a lot kind of going on. It's not like a ton going on in here, but how much of this shit can you just take out?
16 different lines.
Yeah.
It's the same thing. Yeah, it's just.
And then you would integrate x, you would plug in 0 and 6, blah, 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 right? Good, I love it. Right here, what just happened was, no matter what the shit, the minute I get my integral set up, I just do that. We know how to do that. It's just what goes into constructing the integral is different. Yeah,
Stupid question.
I love it.
Will the radius always equal what the function of x is? If we're basing it off that?
No.
Okay.
I'm starting with a very simple example. I'm not going to let them get much harder than this, but they will get harder than this.
Would you show us an example where the radius would not be the function of x? Or
No.
Okay. Well, you're gonna do it.
No, of course I will.
Okay.
That'd be so mean. Sorry, I just love that. Are we back to the thing about yesterday? Like, are you gonna do your job?
Oh, well.
I thought about it. It sounds like too much work. All right. Are you guys cool if I stop here? I mean, that was 1/2 x squared. You plug a 16 in, you get some big ass number. Who cares? Yes. This is where. Now listen. Are you guys with me to the point? I know this is relatively recent for all of us, but do you understand what I mean? Don't get me wrong. I love all math. All math is neat as shit, and I do want to know the answer here. But in terms of the work that we got to do from here, it's not as interesting. Because what would I do? I would integrate x. What's that? What's the integral of x?
1/2 x.
1/2 x squared. Then I would just plug 16 in, because 0 is going to give me 0, and then multiply by this, and that's it. That's the answer, yes? So now it's just a bunch of plug and shove shit. Okay, maybe. Okay. So let's immediately do one more example, and then I have a handout that's got a little more focus to it, but let's see. I have several handouts. This is silly. Let's do this. Let's do this. Volare. Let's do this. Let's have f of x equals x minus 1, x minus 3 in the first quadrant. Can you guys graph that really quickly?
Yeah.
Oh, sorry. One thing, everybody. Well, actually, this will work, but make it negative that. So help me out. What's the x-intercepts?
1 and negative. 1 and 3.
1 and 3. So where's the vertex going to be?
2.
That's insane. So if I just plug a 2 in, 2 minus 1 is 1, 2 minus 3 is negative 1, negative 1 is 1. So this is what I'm talking about, right? But here's what I'm going to do. I'm going to rotate that. I really want you guys, I'm going to go for it. Okay. Because the idea stays the same, and I'm going to show you here we go. You know, just do what you're going to do. I want to rotate it around y equals -1. Can somebody remind me, what's the equation of the x-axis? Y equals 0. So y equals -1 is parallel to that, correct? You guys with me? Okay. So my axis of rotation is here. Does my function hug the axis of rotation?
No.
So what's it gonna have?
A whole.
Hollow part, right? Let me let you guys think about this for a second. Quick side note. Here's a literal cookie cutter problem. Let's say I have a circle of radius 5, yes?
Yeah.
And I cut out of the middle of that a circle of radius 2. Can you guys figure out how much dough I have left?
Yeah.
How would you do that?
Find the original circle. And
Yeah, find the whole thing before I cut that middle part out, right? What would that be?
Pi 5 squared.
So 25 pi
And then
minus
4 pi.
4 pi. Yes? Okay, now keep that in mind. If I rotate this, I really want you to see this. I don't know how to show you this. Go ahead.
I'm just not grabbing right. How is the axis essentially -1? Like, what do we do? How do we get that?
So that would mean the axis is here. So I'm going to take this region and I'm going to rotate it around that.
No, I'm saying, how do we know that's the axis?
Because he told us.
As I told you. Rotate around y equals -1.
Oh, okay.
Yeah.
Okay. Well, there you go.
Okay, I love you guys. So, do you understand that I'm going to end up with this thing? It's going to be sort of like, maybe you can think of it like a possibly like an airplane pillow. You shove your head into it. It's got a middle hollow part, yes? So maybe you shove your head into it and sleep. Yes, on the plane? You guys are all with me?
Yeah.
Okay. What this means is, see if you guys are really cool with this. If that wasn't hollow, I could just do everything like I just did. Here. What's the radius? And what I just said is a trick question, but not really, because I got to show you the whole thing. How do I get the radius? How did we get the radius for the problem we did here? What did we do? I started drawing where? And why did I start drawing at the x-axis?
Because that's where we rotated from.
Good. So in general, put your pen or pencil on the axis of rotation. Draw until you hit something. So here's, I'm going to do this first step, and it's a required step, but it's not the only step. So here we go. If I start here, just pick an arbitrary place in where this exists, and draw until you hit the function. Now just think about how long that is. How long is this?
F of x.
1.
1.
Wait. Yeah. Right? It's just arbitrary. So this is everybody cool? This is f of x. Yes? Sorry, for those of you at home. This is f of x. How long is this?
F of x.
No. How long is this?
-1.
No. How long is it? How long is it? Don't tell me. Yeah, thank you. How long's your dog's tail? -1. It's inside his butt. That's a problem. Vet time. Yes? You with me? Okay. So, I mean, isn't this line one more than this, and this is just f of x? So the earlier question you had, somebody said, is the radius always going to be f of x? No. Because sometimes it's going to go further. It just depends on where they tell me I'm going to rotate it around.
So
Yes?
this one would be f of x plus 1.
Yes, so this radius right here is f of x plus 1, which technically would just be this plus 1. By the way, what is this? This is negative x squared plus 4x minus 3. Okay.
Here's just F of x, right? You don't know what that is.
So this radius here is negative x squared plus 4x minus 2. So if I plug a 3 in, what radius should I get? How long should the radius be here? 1. And when I plug a 3 into this, I get -9 plus 12 is 3 minus 2 is 1. So you can kind of always pick a specific place and just make sure you get the right answer. When I plug a 2 in, I should get 2. -4 plus 8 is 4 minus 2 is 2. Yay! All right. You can always kind of double check to make sure you get actual physical radii you're supposed to get. Now here's the issue. If I use this radius to rotate it, the middle will not be hollow. Because this is going to take the whole thing here and rotate it, so it's going to be like there's stuff here. Does anyone see what I need to do then?
Subtract one.
I need to subtract
That middle area.
the inside, yes. So there's going to be, the radius we just found is the outer radius. We still have to find the inner radius. So when I said in the first quadrant, this is a wall here. The function is another wall. So when you draw your radii, you hit the first wall, that's the inner radius. You go past that, hit the second wall, that's the outer radius. And all we're doing is this. What's the outer radius here in this picture?
5.
And what's the inner radius?
2.
So I'm going to subtract the areas, right? It's the same stupid thing. This is actually what it would look like if I just looked at it this way, yes? Okay, I love you guys. I love it. Did I draw any 3D here?
No.
And I got everything I need to be able to do the problem. So you do not have to draw any 3D. This is a thing that I wish my teacher told me. Young Jeff drew even worse. It would have been great to know I didn't have to draw any damn 3D. Okay, how do we do this then, Jeff? Well, here's what we're doing. You're not going to believe this, but we call this the disk method because it makes little disks. Yes? And again, math people, very creative. So the disk method, Dick, that's good. Everybody appreciate that. The disk method, now it looks like it's Swedish. It's all right, Jeff. We're going to be all right. So the disk method, what it says is it wants to integrate from A to B. It could be f of x or f of y, because you got to realize we could turn this whole thing around. This is actually, let me be less specific. Sorry. It wants to integrate the radius squared, so pi r squared. I always just take a pi out because it's a constant. Now this radius could be f of x, could be f of x plus 1, wherever your rotation axis is. Okay. But this is effectively what the disk method says. Now this could be x or y, so these a and b could be what x does or what y does. Okay. The way I'm rotating this, how do I find a disk? What axis did I move along to find a radius? What axis did I move along to find a radius? The x-axis. So that's why this would be dx. If I was moving along the y-axis to find a radius, it would be dy. So here's the thing. Whatever disk method rotates around, see how this is parallel to the x-axis? It's going to need to be dx. If I was rotating around something parallel to the y-axis, it's going to need to be dy. Because how do I find my radii? Don't I start at the axis and go up? All right, so that would mean I would find a place along the rotation axis, right, and then move. And if I'm parallel to the x-axis, I'm moving in the x direction. That's dx. Okay. So what the hell would this look like, Jeff? So now listen. The method I'm going to use right now is just taking two disks and subtracting them, yes? Do you guys see that? Mm-hmm. The first disk, what's the radius for the first disk? For the outer disk, what's the radius?
F of x plus 1.
Yeah. Let me see if I could do this somehow. Yes, you can do it, Jeff. We don't need all that there. Okay, let me try to do this next to this. So this is going to be the integral. It's going to have to be dx, yes? And what's my x doing across this region? What's the x going from to for the region? What are we rotating? This is too beautiful to believe. Do you see all this shit? Do you see all this shit? Here's my region. What's X doing?
From 1 to 3.
Okay, there. Okay. So X is going from 1 to 3. I'm going to put a pi out here. Yes? So effectively what I'm going to do is this. I'm going to take pi r outer squared minus pi r inner squared, which is exactly what you guys told me to do with this. But we just factor the pi out just because I can. What's r outer squared? What's r outer? I should just...
Negative x squared plus 4x minus 2.
Now I don't think I've said this yet, have I? I think we did. What's r inner? What's this from this one to this other wall here? 1. So this would be minus 1 squared. Now that does suck a little bit. Do you guys see why that sucks a little bit? What do you have to do? You have to FOIL. In fact, you have to FOIL because it's got a middle term, so it would need more than first, outer, inner, last. You have to distribute a lot. You have to write that twice inside, yes? You guys see that? So because the disk method has squares on where the function's gonna go, depending on the function, it could get a little algebraically gross, yes? I try not to make them too busy workish. But to do this, I would have to, by the way, let me see if you guys will. Look, I can write this twice, yes? I can write negative x squared plus 4x minus 2, negative x squared plus 4x minus 2. But since I'm squaring, I could have actually changed the signs, wrote that twice, and it would have been the same answer. Because squares kill negatives. If you have no idea what I just said, just do this. So let's see, can we foil this real quick?
x4.
x4
Minus 4x squared.
4x cubed
Minus 2.
plus
2x squared.
2x squared. This guy gets a turn.
Minus
4x cubed.
yeah. They can solve it.
No, they don't.
16.
Why am I talking like this? I don't know. 4x times 4x is plus 16x squared.
Negative 8x.
Negative 8x. And then this guy gets a turn. Plus 2x squared. Minus 8x. Plus 4. Yeah. X to the 4th minus 8x cubed plus 20x squared minus 16x plus 4. Hooray. That goes here. I mean, all right, look. Compared to some weird ass shit we've done, this you can sink your teeth into, yes? You plug that back in, I'm gonna subtract 1, yes? So I'm gonna get x to the 4th minus 8x cubed. Good Lord, Jeff, can you try to write? Be quiet. Try to teach, good shut up. 4 minus 1 is remarkably enough 3. And I almost don't care what the numbers are because integrating polynomials is always easy, period. Yes? So it'll be pi. Is everybody cool with what I've done? Does anything look wrong? Sorry, some of you guys give me puzzled looks. I'm doing this a little fast. Okay. What's the integral of x to the 4th?
1/5 x squared.
X 5th.
x4.
I could take a factor of 4 up, so it'll be 2x to the 4th. I could take, well, this one needs a factor of 3, so it'll be 20/3 x cubed. This one needs a factor of 2. And this one just picks up an x. And then I evaluate it from 1 to 3, and this is where I'm not going to care, right? And you can throw it in the calculator. I really almost don't care. You guys cooking? You throw a 3 in, throw a 1 in, take the difference. Don't forget to multiply by pi at the end. Yes? And that would be the volume of our creation. Yeah, Jeff. Okay. I don't know. How do you guys feel about this? I mean, I've already shown you one of the harder things for students to get, and I never really understand why. If I have a rotation axis that's here, there's no, how do you always figure out the radius? You put your pencil on the freaking rotation axis, and you draw until you hit a wall, that's the inner radius. Then you draw until you hit the other wall, that's the outer radius. And if you don't have an inner, if your region hugs the axis, you're only going to have one radius. It's not going to have a hollow center. Yes?
Quick question, would you be able to solve this without using a graph? going off soil information.
I mean, sure. I always highly recommend you have a graph as a visual anchor so you can see what's actually happening. Plus, it makes it a shit ton easier to grade because if you make mistakes, I'm like, I don't even know how close you were. You with me?
Yeah.
So, I mean,
Now, I was
you
just
know.
going like the theoretical because how would you find out that f of x plus 1 would be the radius if you don't have a graph to kind of just...
Then just make the graph then.
No,
I got too much to talk about now for that, but just always make the graph, you're good. Okay. So let me give you this one, yeah. Oh, we're all going to be very excited about this. This is one of my most colorful handouts of my entire career. Not that one side, but
this looks disgusting.
What the hell is this? Oh, I've seen. Oh my.
Thoughts on this one? Thoughts on this?
Yeah,
Thoughts, recommendations?
so you might want to put your phone away for this.
all right, guys. So don't worry about the colorful side yet. It's got more than we've talked about yet.
I don't know.
But I mean, real quick thing on the colorful side. Can you see this is basically what we've been talking about? You can see the cross section circles. There's an image of the disc. Here's the, all right. Do you see how this is an outer and an inner? Because the rotation axis here is the y-axis and it doesn't hug the y-axis. They call it a washer. You guys have all seen washers, yes? Little rubber gasket kind of things. Do you notice I hate that they give it its own name because all it is disc method twice. You guys at all with me? Yeah. So washers is not a brand new method. It's just stupid discs twice. Yes? So I always hate when they make it feel like, oh shit, I gotta know discs and washers. No, if you know discs, you know washers. Just subtract the dumb things. And of course, shells are coming. Okay. Don't worry about shells yet. So let's do this. Here's what I want to do with this. I want this to be hyper-focused on setting up what's important. There it is. Okay, everybody look at this first situation. Can you guys... These are the walls that capture the region that I want to rotate around the x-axis. Can you guys take a moment and graph that? And just make sure you guys all understand what x do I want to stop at.
4.
4. Let's try to graph the region that those capture. So graphing square root of x is easy as shit, yes? And you just only do inputs up to 4, right? So one thing is the x-axis, that's y equals 0 is the x-axis, that's one wall. Another wall is x equals 4, and then the main wall is square root of x. So 0, 0, 1, 1, 4, 2. There's one wall, there's another wall, there's another wall. Do you guys see that?
That's like a circle.
So any problem they give us, they have to completely capture a little region. They have to give us enough information. And we saw earlier today, we saw where that a region could be caught by one function intersecting with another function. That's kind of. Where do I want to rotate this around? Or about? Rotate it about the x-axis. So I put a little thing here to remind myself. What does that mean? My integral has to be d what? If I'm going to use discs, it's got to be dx. So what I want us to do, can you guys just take a minute? Can you figure out, don't say anything, figure out what the radius would be and then try to set the interval up.
You start at the
You hit something.
yeah, you hit the wall right here. Because there's no inner outer radius here. There's just like
So this could be like a f of x.
But they just
I did starting in like 4 minutes.
Alright guys, so how do you always find the radius? You start at the,
X-axis.
no, you start at the,
X-axis.
Rotation.
no, you start at the rotation axis. So I'm said, how do you always find the radius? Start at the rotation axis.
And go up.
Go
until
up.
you
Now
hit
is this gonna have a hollow? Is this gonna need an
No.
inner radius?
No,
How do you know?
because
How do you know?
because it's hugging the.
It's hugging the axis of rotation, yes. There's no daylight through there. So if I start at the axis and I go out to my only wall, how long is my radius?
Alphabet.
Which is? What is the f of x? Square root of x. Okay. I love you guys. What's the answer? The answer. So can you have you guys try to set up the integral? Now that you know the integral is dx, and how did we know that? Because we're using discs, and the rotation axis is either the x-axis or parallel to the x-axis. dx. If it was the y-axis or parallel to the y-axis, it would be dy. So I got pi. What's my integral gonna go from to?
From
From
square root of x
0
to
to
x.
4.
No.
0 to 4.
No, real quick. Is everybody cool with it's dx, yes?
Yeah.
Okay. When I look at my region, what is my x doing across the region? It starts at?
Oh,
0
I
And it goes to?
4.
Okay.
I thought you were talking about it's not pi over
Now what's my
square-
radius?
square root
Rad
of
x.
red x.
Rad x, and what am I gonna do with it?
X. Because you're gonna square it. it's gonna be
Square
x.
it. Okay. I'm with you.
Yeah.
You're just one step ahead. Stop doing that. Stay with me right here. So this is just, again, this is adding up an infinite number of circle areas. Or you think of it as the thickness, so you're adding up a bunch of little pennies, and that's gonna make the whole volume. This is really nice because the square root of x squared, like you said, is x. And the integral of x is,
1/2 x squared.
and I wanna go from 0 to 4.
So how do I know when something's a disc versus something's a washer?
How do you know? Anybody can tell me?
By the shape of it.
No.
Oh, if
This is a wall here. Where's my axis of rotation?
it's hugging.
Here.
If it's a
Is there
washer-
any
It's a washer if it's
daylight between those two? Is there any space between those two? Spice? Sure, jail. No, there's no space between those two. So it's hugging the x-axis. That is not a technical math term, but that's what makes the most sense to me. It's hugging the x-axis. So there's not going to be any hollow when I rotate
Other than
this.
the x-axis.
Like, it's touching the.
It's touching.
rotation.
Is it hugging the y-axis? Is this region hugging the y-axis? Guys.
Look, طلع على هاي.
Is this region hugging the y-axis? No,
Yeah, so is it?
because there's part of it that's nowhere near the y-axis.
Is it disc?
That makes
So-
it a washer.
On the interval on which it's defined, from here to here, it's on the axis. From here to here, it's not.
That
disc?
that was
This is
the-
gonna have a hollow inside. If I was rotating around the y-axis, yes?
Is- you get it?
Yeah, so when the dotted line touches the axis thing, that's
Yeah.
that's a what? That's a disc.
That's a disc. When it's not
Now, what's the only
so-
difference between the problem we just did and this one?
Y is equals negative 2.
Yeah, so my axis of rotation is down here. My region is exactly the same. So what's gonna happen now? If I start trying to figure out the radius, I put my pen on the axis of rotation. When I start to draw, do I hit a wall? What's the first wall I hit?
Or the x.
Which is what? So let's see. So I start here, and I go until I hit here. Yes? So yeah, 2. That's huge. And then if I instead, so that's going to be the inner radius. So the inner radius is 2. If I go from here and I go all the way out to there, it's going to be this much plus 2. Yes?
Well, so rad.
So what's my outer radius going to be then?
Rad x plus 2.
Yeah, rad x plus 2. So this one's going to suck a little more. Too bad for everybody.
So it's rad of the inside because the inside is always the bottom and the outside is always the top of the.
No.
Well, the inside's always the first wall you hit,
Uh-huh.
and then the outer one's always the second wall you hit.
Okay.
Yeah. I don't know if you guys have ever seen coaxial cable. No, that might be too freaky, but a washer, I guess, is the best one. You have an inner radius when you hit the inner wall, and an outer radius. Sure, Joe. Last clue about it. Outer radius when you hit the outer. Okay.
So the inner side is the inner is 2 because you went up 2 spaces to hit it, right?
Yeah.
Yeah.
And
If
and the square root of plus 2 out of that. The square root of that gate.
How long is this? Well, how long is just this piece right here? Square root of x, yes?
Yeah.
And how long is this piece?
2.
So how long is the whole thing?
Square root
Yeah.
of 2.
So
Okay.
a radius will always be from the center to wherever you're stopping, yes? So the inner one stops at the inner wall, the outer one stops at the outer wall.
So it's the inner one.
Do you guys see why this one's gonna suck a little bit?
Because you have to do the interval of 2.
Well, is it gonna be dx or dy?
DX.
Dx, because I'm rotating around something parallel to x-axis, yes? So it's gonna be dx. I'm gonna have a pi out here. The limits are still gonna be 0 to 4, yes?
Yeah.
But what's gonna be in here now? It's gonna be our outer squared. What's our outer?
Rad x plus 2.
And that sucks. Doesn't suck as much as some other stuff we've done, but it certainly sucks compared to the first dude, because what do I have to do with him?
Subtract it from.
Now, what do I have to do with
you
him?
have to,
Foil him.
foil him.
Yes?
Yeah.
So that first that was nice. Look at that. Look at that. Do you remember that? Do you remember those days? So, I don't know. Yeah. So here you get x squared of x times square root of x is x. 2 rad x. 2 rad x is 4 rad x. 2 times 2 is 4. That's crazy, Jeff. Minus 4. That's kind of nice. Those go away. That's nice. Is everybody with me?
Yeah.
I'll write that twice. Catch up to me. How do I integrate this?
1/2.
You can write this as 4x to the 1/2, yes?
Yeah.
So it'll be, 1/2 x squared plus,
2x.
see, 4 times, it'll be x to the what power now?
3/2.
Good, 3 over 2. So I'll have a 2 over 3 out front. Thankfully, these kill each other, yes? And I want to evaluate that from 0 to 4. Pi 4 squared 16/2 is 8 plus 8/3 times the square root of 4 is 2 cubed is 8. When I plug a 0 in, everything is 0, so I'm not going to worry about him. Be very careful. Do you see how 0 makes everything 0? Does it do that for every function?
No.
What's the cosine of 0?
1.
What's each of the 0?
1.
So don't just not plug 0 in. Actually make sure, oh yeah, just everything goes to 0. Okay. And then whatever the shit this is. Let's see, 64/3. So let's see. You could do it, Jeff. 8/3 of 8 plus 1/8. Screw it. 64/3 plus 24/3 is 87/3. Is that right? No, 64/3 plus 24/3 is 88/3
Yeah.
times pi.
Yeah.
Yeah. Okay. All right, let's do this one. Look at this. This is very exciting. Why is this one very exciting for me?
Or just the y-axis.
Yeah, Jeff, whatever. Whatever. What do you guys have to do first to be able to graph this region?
So the y-axis has to stop at 1/2.
What do you have to do first, sorry?
You have to
The
graph.
y-axis has to stop at 1/2. The y-axis has to stop at 1/2, like the one you plot the y has to stop at 1/2 x.
Make the function.
Sure. Yes.
Make the function equal.
Yeah. Set each function equal to each other. Did I give you enough walls already? No, the walls I gave you, I have to figure out where they meet so I can see what they close. So I want you to rotate the region enclosed by those walls. The other ones were easy, because one wall was an axis and the other wall is just a straight line, and the other wall is a function. This is two functions over walls. So I have to figure out where they meet. So set them equal to each other. How do I solve this?
Times 2 times power.
Square?
Yes.
Okay. So x equals x squared over 4. How do I solve this?
Times 4.
Is everybody cool with that? Square both sides to kill the radical.
Multiply by 4.
Multiply by 4. Are my x's different powers?
Yeah.
So then I want to get it equal to
X. Or
0. Factor. Solve. Okay, so that's going to happen sometimes. So 0, 0 they meet. What other point do they meet at?
4.
4 what?
2.
4, 2. So if you put 4 in there, you get 2. Put 4 in there, you get 2. That's kind of a check to make sure they meet at 4, 2. One of these is a straight line, so I don't have to think too much about that one. The other one's a square root, and of course that just curves out. So this is a very skinny, sickly looking blue banana, poor little dude. And we want to rotate this funky ass dude around the y-axis. What is immediately, well, let's see. Let's do this one step at a time. Do the next thing you know you can do. So I'm going to put for myself, I always do this for myself to remind future me what the shit's going on. So I'll draw a little thing going. I'm making it go this way. Can you guys find the radii? How many radii do I need?
2.
Why?
There's an inner and a.
Because my banana ain't hugging my axis of rotation. There's space between them, so it's going to be an inner. Because when I start it there and I draw, I'm going to hit one wall, and then I start over and I hit the other wall. Yes, there's a lot of different ways to notice when I have an inner radius and an outer radius. Can you guys take a minute and figure out what the inner radius is, what the outer radius is? Don't say it out loud.
No. I don't know actually. I know it's because that's 1 and then there's 1.
All right, so here's my axis, yes? And if I draw from my axis out, what do I hit first?
The
Square root of x. And then, of course, that must mean the other dude's the other one. Our outer is going to be 1/2 x, yes? Now, here's the major problem, though. This is what yeah, Jeff. This is why I didn't want to do this first. Damn it. So here's what's going on. What is my integral going to have to be d what?
dy.
It's going to have to be dy. Now, what does that mean? That means that everything in the integral has to be in terms of y. Currently, my functions are in terms of
X.
that sucks. Can you just solve for x, though? Can you solve this for x?
Yeah.
What do you get? Y squared. Can you solve this one for x?
Yeah.
What do you get?
2y.
2y. So what is my inner radius actually? So if it goes here, what did I just hit?
Y squared.
Yeah, so my inner radius is y squared. And then my outer radius
It's 2y.
is 2y. There we go.
But wouldn't
Go ahead.
for the outer radius, wouldn't you have to do the 1/2 x plus the rad x for the outer?
No. Why? No. It has,
Well, because
it
on
doesn't
the,
give a shit where this other wall is. All I care about is how far away is this dude from the rotation. That's all I care about. I don't care where this other guy is. He could be doing whatever weird shit he wants to do. It doesn't change how far away this guy is. Okay. So this would be pi. This is dy, yes? So what am I going to put here and here?
We can see.
Sorry. This is dy. What am I going to put here and here?
Y squared.
0 and 2. Because what's y doing across this region is going from 0
To 2.
to 2. Do you guys all see that?
Yeah.
So, I really want you to notice. How did I know it was dy? Because I'm rotating around the y-axis. I'm trying to do discs. All right. So that means several things. These numbers have to tell me what y is doing. Everything inside has to be in terms of y. Okay. Was it easy to solve these two equations for x? Yes. Is it always going to be easy to solve the equation for x? No. That's why we have a second method. The second method takes over if discs fail. This discs won't fail because we could solve. So there's going to be the outer radius squared. What was the outer radius?
2y.
2y. Minus the inner radius squared.
Which is y squared.
And then it's still a relative, that's an easy integral, yes? That's just a polynomial. Maybe. I always want you to keep sight of what's going on. We're finding the radii, because the idea behind this is just adding up all the circles. And if I want to add up the circle areas, I need the radius, this. Right? Squared times pi. And since pi is in both, I can just factor it out. That's kind of nice. I almost don't care about what the answer is. I do, but I don't. In the interest of time, I want to say, here, I want to give this to you. We're gonna barely do anything right now, so just
I was gonna say the same thing. Oh, I need to know. You're not just doing that.
So
So just to really put the problem in your face.
He gave us 5 minutes. Well, I will love.
If I wanted to do this problem, by the way, look at this beautiful function. If I wanted to do this problem using discs, yes?
Yeah.
I'm rotating around the y-axis. I'm going from 2 to 4. I don't know why I put A and B here, it's okay. There's a little better picture down there. I'm going around the y-axis, correct?
Yeah.
So my integral is going to have to be d what?
dy.
So whatever functions I put inside have to be functions of y. This is currently a function of,
Yes.
so let me really go over what I just said. In order for discs to work for this problem, the only way discs could work is if I can make the function I'm given in terms of y.
So you flip
Because
that to
discs
y?
need it to be dy. Why does discs need it to be dy? Because I'm rotating it around this. And this is how I would find my radii. I would locate them along the y-axis. That's why it's got to be dy. Can you solve this for x?
Yes.
Oh, teach me.
No.
I will take your place.
I learned it.
Do you understand what's happening? If it was this, to be really honest with you, I could solve that for x. I would use a weird freaking interpretation of a quadratic formula.
Can't you use? No.
What's that? No, I'm not saying anything about calculus right now. What did we just do? What did we just do here and why? Why did we do this?
So it could be.
Because what did the integral have to be?
dy.
Because I was rotating around the y-axis, yes? I have to then get x as a function of y, because what's the only things that an integral dy can handle is y stuff. So can I just throw this shit in as a radius in here?
No.
No, because this guy needs y. So can I solve this for y? I'm talking algebra right now, yes?
No.
Hell no. I could solve that. I could. solve that for X. I don't know which way I just said it. That would be horrendous. It would suck so bad. So I imagine that, forget about it. The minute I put a cube, no. So that tells you I have to have another method if I want to be able to do this volume. So the really neat thing is, this is where we truly get some bundt cake pans. So what, I told you I wasn't going to do much. There's a rectangle again, yes? And if we rotate it, we make this cylindrical shell, which is why we call them shells. It's the shells method, yes? And we're eventually, so next time I'll show you where these equations come from. It's just the area of, the surface area of a cylinder is what that comes from. Sort of like the area of a circle, but instead of a circle, we now have a cylinder. Okay. So we'll do that first thing Monday, and then the rest of Monday will be review for the test.
I want to sleep and go home.
Woo! All right, guys. Everybody got a practice test, practice final? Okay. All right. Have a good weekend.
How many handouts did you say, like 5?